So for this video, I'll be going over integration with partial fractions. Normally it would take place when we have polynomials in the fractions, both in the numerator and the denominator. But let's just go over all of this one by one. So this is obviously the two questions I'm going to be going over in this video. Just make sure you go with respect to the timestamps. Example 1 over here and example 2 over here. Okay, let's get straight into the introduction. So whenever we are integrating with partial fractions, what we need to consider is the following. So let's say, for example, we have the integral of something. Let's say we have the integral of x squared plus 3, right? Divided by, and then we have brackets that consist of just random variables. But let's just say this over here quickly, for example, okay? So what we have over here, let's say we have x multiplied by x plus 1 multiplied by x plus 2. It can be anything in the brackets, just as long as they're multiplying each other, like this, right? So what we are going to be doing is the following. We are going to take this outside of the integral. Also, this is with respect to x. We're going to take this fraction outside of the integral, and then we are just going to let it equal to a divided by whatever is the first one over here. So a divided by the first bracket, which is x, plus b divided by the second bracket, which is x plus 1, plus c divided by the third bracket, which is x plus 3, in this case over here. So that is what we're really going to be doing. It doesn't really matter what order the brackets are. Let's say you maybe, for example, swap these two brackets around in the beginning. It doesn't matter actually, because that's why we have the plus signs, right? It kind of helps us. So if this is still a little confusing, I'd rather go into the first example and then we can go through this together. And then you'll see how there will be a flow, because the first example is going to be a nice easy one. And then the second example is from one of the examination papers that I've actually found on the internet. So I'm going to go over that with you guys. So let's start with the first example. Okay, so I know the introduction wasn't too crazy with the explanation, but once again, if I did have to explain the introduction like fully, I'd most probably be doing the question, which is not what I want to do right now. Okay, so first of all, what do we see over here? We see a polynomial here in the numerator, and we also see a polynomial in the denominator. But what do we notice about this polynomial in the denominator? Well, it has a common factor of x, so why don't we just take it out? So we're going to say this is equal to the integral of 2x plus 3 divided by, we're going to take out x as a common factor. Well, let me just write it as a round bracket for now. Multiplied by x minus 1 with respect to x. And now what do we see? We have one bracket here, which is x, and we also have a second bracket, which is x minus 1. So we can actually follow this rule over here. Okay. So when you do get it in this form, when you have the brackets in the denominator, and make sure you keep it like that, then you can start with the partial integration technique. Okay. So what are we going to do first? First of all, you're going to say suppose that 2x plus 3 divided by x multiplied by x minus 1, right? So basically, like I said, you take this whole fraction out on its own, and then you're going to let that equal to, with respect to how many brackets there are. You can see there's two brackets, so we're only going to be dealing with a and b. So how are we going to do this? We're going to say that this is going to be equal to a divided by the first bracket, which is x, plus b divided by the second bracket, which is x minus 1. Okay, great stuff. And now from here, what do we note? We want to get rid of this denominator, right? Because we want to have like a line of equation, a line of an equation. And this is how we're going to go about doing this, right? So we can basically see that the LCD, the LCD of this side is going to be x into x minus 1, right? Which is basically the same over here. So which means we're going to try and cancel out the denominators. So this is how we're going to do it, right? Well, we are going to multiply both of these, both the numerator and the denominator, by x minus 1 to fill in the gap. So we're going to have a multiplied by x minus 1 divided by x multiplied by x minus 1 plus, and then for the b1, we're going to multiply both the numerator and the denominator with x, because it's missing the x in the denominator. So it's going to be b times x divided by x into x minus 1 over here. Great. And this is equal to 2x plus 3 over x into x minus 1. And then we can just, because these denominators are the same, we can just put these fractions into one fraction. So it will be written as a into x minus 1 plus b times x. Okay, all divided by x into x minus 1. And then we have 2x plus 3 divided by x into x minus 1. And now what do we note over here? We can cancel these denominators because they're exactly the same. And then whatever is in the numerator is going to fall into one line of equation. So we're going to have 2x plus 3 is equal to a into x minus 1 plus bx. Okay. Now we've actually made good progress, but you're probably wondering, what are we going to do from here? Well, this is the part which actually requires you to have some great knowledge of mathematics. So we're going to keep this side the same quickly, 2x plus 3, but we're going to multiply the a into this bracket over here, such that we get ax minus a plus bx. And then what do we see? Well, first of all, we have a common term. We have like terms, which is in terms of x, right? A and b both have the variable x, so therefore we can take out a common factor. So I rather want to first do it like this. You can write it as ax plus bx minus a, so that you can get the x's right next to each other. Okay, so now you can take out a common factor. So you can take out a common factor like this. It's going to be a plus b into x minus a. Okay, 2x plus 3. And also, I just want to let you know, a and b are constants. Okay, a and b are constants in our case over here. So because they are constants, and we would like the constants to be equal to each other, this is where we're going to actually this is where it gets a little tricky, right? Well, not really tricky. I'm sure you'll understand it immediately as soon as I tell you. What do we note over here? This has a term of x. This also has a term of x. This is a constant, and this is also a constant. Meaning, because this is an equation, these two actually have to be equal to each other. So what if I told you that 2 is equal to a plus b, and positive 3 is equal to a? What if I told you that? So that we can make this equation true. So this is what I'm trying to say over here, right? So I'm actually going to do it like this. I'm going to be drawing a line over here so that I can divide the section. What I'm going to be showing you is you're going to let 2 be equal to a plus b. Because remember, both of them share the variable x. So which means they have to be equal to each other, right? So therefore, you're going to say that a plus b is equal to 2. But we don't have enough information to actually solve for a or b. Now this is what I'm going to show you here. So I'm going to also separate it. What do we know? We also know that positive 3 is equal to negative a. So we can say negative a is equal to positive 3. And can you see over here, we only have one variable that we can actually solve. So we know that this can just be a is equal to negative 3, because we can multiply both sides by negative 1. Therefore, we know what a is. So which means we just need to solve for b over here on this side. So b is equal to 2 minus a. And then we can plug in our a that we found. B is going to be equal to 2 minus negative 3. Therefore, b will be equal to positive 5. So 2 minus minus 3 is just equal to 2 plus 3, which is equal to 5. And there we go. We found b. And then what do you remember from the beginning? If you remember from the beginning, we let this fraction over here be equal to these two terms here, where we didn't know what a was or b was, but now we know what a is and b is. We know that a is equal to negative 3 and b is equal to 5. So we're just going to plug that into this side over here. So I'm going to now divide it again like this, so that we're done with that section. Okay. Now from here, we can say that I'm just going to write it like this in the form of an equation. 2x plus 3. So it was 2x plus 3 divided by x into x minus 1, our initial fraction that we took out, is going to be equal to our a divided by x plus b divided by x minus 1. And now we can just plug in our a and b values. Our a value is negative 3 divided by x plus b value, which is equal to 5 divided by x minus 1. And this is equal to, oh, I mean, you don't really need to write that down. Okay, so what do we note over here? Well, we can literally just replace this with this in our integral. So this is how it's going to look. So we're now going to have the integral, so it's going to be equal to the integral of, it's going to be, I'm just going to write down the bracket here. That's going to be negative 3 over x plus 5 over x minus 1 with respect to x. And then what we can do is we can take the integral in both terms, right? We can take the integral into this term and then into this term as well. And then therefore, we can say this is the integral of negative 3 over x with respect to x plus the integral of 5 over x minus 1 with respect to x. And now guess what? We can actually, well, to make it a little bit easier for ourselves, we can take the constants out, right? We can take the negative 3 out to the outside, and we can also take the 5 to the outside. So let's quickly do that. So therefore, we're going to have negative 3 integral of 1 over x with respect to x. And we're going to have, it's positive 5 that we are taking out, so therefore it's going to be plus 5 integral of 1 over x minus 1 with respect to x. And now we can integrate. And what do we know about the integral of 1 over x? Well, the integral of 1 over x is just, with respect to x, is just equal to the natural log of absolute value of x plus c. So that's what we're going to do with both of these integrals. Therefore, it's going to be negative 3 multiplied by the natural log of absolute value of x, because x is in the denominator for this one. We're going to have plus 5 multiplied by the natural log of the absolute value of whatever this fraction is, which is x minus 1. And then we're going to have plus c. So that was the first one. So if you find this a little bit tricky, I do recommend going backwards, because I try to explain it as much as I could. But otherwise, this next example will basically go over the more complex one. And this was the one that I found from one of the past papers of one of the other universities. So let's go through this one quickly. Alright. So for this one, we also have the same thing. We have the polynomial on the numerator and the polynomial in the denominator. Now, with partial fractions, in order to get to partial fractions, we need to factorize the denominator so that we get a whole bunch of brackets. So how are we going to do this? Well, first of all, we're actually just going to try and factorize the denominator, literally what I just said right now. So we're going to have 5x plus 3 divided by, well, what can we see already? We can see that x is a common factor. So let's take that out as a common factor. So we have x multiplied by, and then, or if x as a common factor, then we're going to be left with x squared minus 2x minus 3 with respect to x. Now here's the part where it gets a little bit tricky, okay? And it would be understandable if you don't know what to do. Now, let's just take note of this, right? So, let's look at this negative 2x, right? And I want to just quickly break it up for you. And I know this is a little bit of a crazy one to go through right now, especially if it's during examination times, which I find is actually crazy. We're looking at negative 2x, right? Well, if we wanted to kind of be the same as this negative 3 and this 1 over here, because you want to factorize it, remember, that's the whole point. No, I'm just kidding, guys. So basically, you don't have to look at this any further. I'm just trying to get to you right now. You can actually just factorize it simply because this is our trinomial that you can just factorize normally. Okay, so it's 5x plus 3 divided by x into, well, we can factorize this as follows, right? It can also be factorized as x minus 3 into x plus 1. If you didn't know how to factorize, then I'm sorry, brother, but it's university now. This is grade 9 stuff, actually. So yeah, anyway, can you see what we have just done? We have 3 brackets. multiplying each other in the denominator, meaning we can now break them up. Okay, we can take this fraction, which is being integrated, outside of the integral. Okay, so therefore what we're going to do is we are going to suppose that 5x plus 3 over x into x minus 3 into x plus 1, I'm going to keep the bracket here, is going to be equal to a divided by what's the first one is x plus, it's going to be b divided by the second one, which is x minus 3, and then the third one, which is going to be c. Also, just take note, if you do have 4 of them, or let's just write this one first, it's going to be x minus 1, right? I mean x plus 1. I don't want to make those mistakes again, okay? So we have 3 brackets. And take note, if you do have 4 brackets, then you can add plus d over whatever fourth bracket you have, okay? You can just keep adding terms. Okay, great. Now, as you can remember, we just want to eliminate the denominators. So this is what we're going to be doing. We can see that this one actually has an LCD of x into x minus 3 into x plus 1. Okay, so therefore we can write it like that. We just need to add in the numerator whatever's missing in the denominator. So we're going to have a into x minus 3 into x plus 1 divided by x into x minus 3 into x plus 1. This is plus b into x plus 1 into x divided by x into x minus 3 into x minus 1. And then let me just zoom out over here. Then we're going to have plus c divided by, well, I mean, on top over here, we're going to have c into what is missing, x and x minus 3. Okay, so now we're going to have x into x minus 3 into x plus 1. Okay, and then obviously we just need to write it into one fraction. We're going to have this be equal to a into x minus 3 into x plus 1 plus b, let me just close this bracket here, plus b into x plus 1 into x plus c into x minus 3. Okay, and this is all divided by, x into x minus 3 into x plus 1. Okay, and then obviously we have this over here, which is still the same thing. So what I'm going to do is I'm just going to copy and paste. Okay, now we have that equal to this, right? And what do we notice over here? Well, these denominators can cancel now. Okay, now we are left with the one line of equation. So we're going to have 5x plus 3 is going to be equal to a into x minus 3 into x plus 1 plus b into x plus 1 into x plus c into x minus 3. Great. Now from here, like we did in the last example, we just need to actually multiply the brackets in. We need to simplify, okay? So first of all, we need to actually use the FOIL method on here. So this is actually just going to give us x squared minus 2x minus 3. Okay. And then over here, what we're going to have is plus b into, we're going to multiply these brackets as well. We are going to have x squared plus x, and then plus c multiplied by, we're going to deal with this bracket over here. It's going to be x squared minus 3x. Alright, and this is equal to 5x plus 3. Okay. Now, obviously, we need to just multiply all of the constants into the bracket. So a, b, and c, we need to multiply them into the bracket. So I'm going to give a little bit of space here. 5x plus 3 is equal to, we're going to multiply the a into this bracket over here. So it's going to leave us with ax squared minus 2ax. Note that I'm treating the a as a constant, but I normally like writing the actual numbers out first and then the a, or the b, or the c, whatever. And then this is going to be minus 3a. Okay. And then we're going to have plus b into, well, we're going to have x squared plus b into x. then this is plus c into x squared minus 3c x. Okay, so that's what we are left with. And then we just need to add and or subtract like terms, okay, from here. So that's what we're going to be doing. We're going to have 5x plus 3 is just going to be equal to, what do we have over here? Let's look for all the x squares. Well, the x squared, we have ax squared, and then we have bx squared, and we have cx squared. But note how we can just write, we can actually just take x squared as a common factor. So therefore what we're going to have is we're going to have positive a, so this is positive a plus b plus c, which all falls under the term of x squared. Okay, what else are we going to be looking for? Well, we have negative 2ax for when we're only working with the x now, okay, the one with the x. So we have negative 2ax, positive bx, and negative 3cx. So we're going to take out x as a common factor for all of those. So it's going to be positive. So we're going to take positive bracket. And what did we say? It was negative 2a. What was the other one? It was, so it's all the blue ones. It's going to be plus b. And it's minus 3c. And then x is the common factor there. And then what we are left with is the constants. Well, the only constant we actually have is a negative 3a. So it's going to be minus 3a over here. Okay. So here's where it gets, well, I mean, this is where it actually gets a little bit crazy because we haven't done this in the last example. Well, what do we notice over here, right? So yes, we have x on the one side, which is represented as this whole thing. And we also have a constant, which is also represented here. But what about this one? What about the x squared? Well, remember that what we need to do is, well, I mean, we know that 5 is going to be equal to this whole bracket over here, right? Because it's represented by the x. And we know that the positive 3 is just going to be equal to negative 3a. But what is this one going to be equal to? A plus b plus c x squared. Now, just pay attention carefully here. What I am going to do is I'm going to add a term with x squared such that it still makes the equation true. So if we add 0 x squared, what we note is that if we simplify, 0 will multiply with x squared, just giving 0, and it will fall away from the equation. But if we add 0x squared, that is perfect. Now we actually know a value that is represented by x squared, and we know that 0 will be equal to a plus b plus c. Okay. So that's what that's what I was trying to allude this entire time in the first example. Okay. Great. Now that we have a value for a plus b plus c with x squared, representing x squared, we can now do the equation. We can actually now let the things equal to each other. So this is what we're going to be doing. So I'm going to do it in red rather. So we're going to have a line that separates now. We're going to be doing all of this in red. So what do we know? We know that a plus b plus c is equal to 0. So a plus b plus c equals to 0. Okay, so that's the one side. Now the second side is going to be where 5 is going to be equal to all of this, represented by x. So we're going to have negative 2a plus b minus 3c is equal to 5. And then it's going to be the negative 3a is equal to positive 3. That's the other one. Okay. Cool. So we're going to have negative 3a, which is equal to positive 3. Okay. Now, first of all, with all of these equations here, the one that we can find first is just what is the value of a. So we know that we can divide both sides by negative 3, and we'll get a is equal to negative 1. So there's our a value. Now this is going to be where we're going to constantly swap from equation to equation so that we can determine some values, okay? So first, let's focus on this equation quickly. So we know the value of a, which is negative 1. So we're going to have negative 2 into negative 1 plus b minus 3c is equal to 5, right? And then we know that this will be equal to positive 2. So it's going to be positive 2 plus b minus 3c. And if we want it, we need to minus both sides by negative 2 so that we can get rid of this positive 2 here. So then that means we're going to have 3 on the other side. It's equal to b minus 3c. Okay. Great. Now what can we do next? Because we still have 2 variables. Well, let's just consider this equation here quickly. Let's try and manipulate this, because we came to a standstill on this side. So let's try and deal with this equation here. So we know that a is equal to -1, so we have -1 plus b plus c, which is equal to 0, and we're just going to plus 1 by both sides, so we're going to have this one we're going to get rid of this 1 on the left hand side, so it's going to be b plus c is equal to +1. Okay, great stuff. And now from here, well, which one would it be easier to do? Well, if we make b or c the subject of the formula, doesn't that mean that we can just plug in those values over here? Okay, so what I'm going to be doing, and this is what I'm trying to say over here, I'm going to make b the subject of the formula here. So b is going to be equal to 1 minus c. We're just minusing c on both sides. And then now we have the value of b for now, okay, in terms of c. And this is what we're going to be doing. We know that b is equal to 1 minus c. So we're just going to plug that in. So it's 1 minus c minus 3c. And what do you notice? We have only one variable. So we're just going to do the like terms. We're going to have 1. And then this is minus 1 minus 3c, which is equal to minus 4c equal to 3. Okay. And then we're just going to get c on its own. So it's minus 4c is equal to minus 1 by both sides. It's going to be 2. And then what we're going to be left with is we need to divide both sides by 4c. And if we divide both sides by 4c, or negative 4c, we're going to have -1/2. Okay. So there's our value of c. Okay, so let's just extend this a little bit more. So now we have the value of c, and now we have the value of a. Now what we can see is we can just plug in our value c over here now. So b is going to be equal to 1 minus, and what is our value of c? It's equal to -1/2. Then therefore b is equal to 1 minus -1/2. That's just going to be 1 plus 1/2, which is equal to 3/2. And there's our value for b. So that was a little bit of a swap and go, because we constantly had to swap the whole time. But now guess what? Hey, we've made so much progress so that we can find the value of a, b, and c. Sorry, a, c, and b, or a, b, and c, whatever. So now that we have those values, we can just plug it into whatever we had initially over here. Okay, great stuff. So now what we remember over here is that we have, I'm just going to copy and paste it. I'm going to just be honest with you, I'm not going to be writing all of this stuff down. Let's just copy it here, and then we are going to paste it. Okay. Okay, it did look a little bit weird, but I fixed it quickly. Okay, so this is what we had initially. But now what we can do is we can just plug in our values a, b, and c. Okay, so then this is just going to be equal to, what is a equal to? A is equal to -1. So we're going to have -1 over here. And then we're going to have divided by x. Plus, what is b equal to? B is equal to +3/2. So it's +3/2 divided by x minus 3. Plus, and we are going to have -1/2. So this is actually going to be negative. So it's going to be -1/2 over x plus 1. Okay. And now what can we do from here? Well, what do we know about this? Isn't this just over here represented over here? So that means we can replace that in our integral. Therefore, what we are left with is the following. What we can say is now this is going to be equal to the integral of, we're going to put our bracket over here, we're just replacing the stuff. So I'm just going to put the negative here, -1 over x, plus we're going to have, or let me just keep the -1 for now, plus 3 divided by 2 over x minus 3 minus 1/2 over x plus 1. Okay, with respect to x. So we just replace whatever we had initially, that that fraction, we just replace it with all of that stuff now. And now from here, we can just take the integral into all of them. So we're going to have the integral of -1 divided by x with respect to x, plus the integral of 3 over 2 divided by x minus 3, minus the integral of 1 over 2 Also, sorry, this is with respect to x, minus the integral of 1 over 2 divided by x plus 1 with respect to x. Perfect. And now let's just take out the constants. We can take out all the constants. If we take out the constant over here, we have negative integral of 1 over x with respect to x. And then if we take this constant out, we're going to have positive 3 over 2 integral of 1 over x minus 3. Sorry, x minus 3 with respect to x. And we're going to have minus, we take out this constant here, it's going to be a half. Integral of 1 over x plus 1. Just write that properly. With respect to x. And now we can integrate. That's perfect. Also, let me just keep this negative 1 for now. Okay, so what can we do now? We can do the integral. And remember from the other example, we know that the integral of 1 over x with respect to x is just equal to the natural log of absolute value of x plus c. Okay, so we're just going to do that. So therefore, what we're going to have over here for the first integral, it's a negative natural log of absolute value of x. Okay, that's the first integral. Then we're going to have plus 3 over 2 multiplied by the natural log of absolute value x minus 3. And then the next one we're going to have minus a half multiplied by the natural log of x plus 1. And then we just end up with plus c. And that is the final answer.